Good morning. Okay, magnetic field due to a current carrying conductor we were discussing in the last class, right? So let's continue now. Okay, about the magnetic field calculation. Different examples we will take it. Right. So magnetic field due to a current carrying conductor we have calculated. Okay. So if it is a straight conductor, the magnetic field, how much it will come? Mu naught pi 4 pi I by A, where I is the current in the conductor, A is the perpendicular distance of the point from the conductor. Okay. And alpha beta. Alpha beta is what? It is the angle made by the point with what? With the ends of the wire. So now we have some special cases like infinite conductor or very long straight conductor. Infinite conductor or very long straight conductor, what will happen? The angle made by the end point, okay, angle made by the ends of the rod is going to be how much? It is going to be 90 degree in both the cases. Okay, so we got our result as what? Mu naught I by 2 pi A, we got it. Same way, if it is semi-infinite, then mu naught I by 4 pi A, we got it. And one more thing, if a point is lying, okay, if there is a point where we want to calculate the magnetic field lies along the direction of current itself, then what will happen? Then the magnetic field at that point is going to be what? Zero. Understood? Clear? Let's discuss some example on that. अब आप जाइए. Okay. Okay. So now if we calculate, let's take an example and try to calculate the magnetic field using this straight conductor situation. Okay. So in this example, what is given to us? A square loop is given to us. Okay. And the side of the square is given as A. This is also given as A. And current is flowing in the square loop like this. Same current is flowing everywhere. I. We want to calculate magnetic field at the center of the square. Find magnetic field at center of the square. Okay. So if you want to calculate magnetic field at the center of the square, what you can do it? Can you break this square into four straight conductors? Can you break this square into what? Four straight conductors? And we will calculate magnetic field due to each straight part. And after that, we will add those magnetic field vectorially. Means what? If these magnetic field comes in the same direction, what we will do? We will add it. If they comes in opposite direction, then we will subtract it. Understood? So please tell me what is the net magnetic field coming and what is the direction coming. Okay. Chili, please try it and tell me how much is this coming. Just use the straight segment, okay? What we have learned for the straight segment, okay? Let me calculate due to this segment, what is the magnetic field is coming. So first of all, I need what? I need the perpendicular distance. So perpendicular distance will become A by 2. The next thing I need that the ends of the wire is making how much angle with the this point. So it says square. So we can say that पानी गिर जाएगा बाबू. It says square, so it will become 45 degree and 45 degree. Okay. So it means now everything about this side is known to us. Okay. So what will be the magnetic field due to this one? So B will come mu naught by 4 pi. Current is I. Perpendicular distance is A by 2. And what are the alpha beta angle? The alpha beta angle is 45 and 45 degree, right? So if we calculate it, what will happen? Mu naught by 4 pi. What is we have calculated here is due to one side, isn't it? Same way we have to calculate it for all the four side. Now, and at the same time, we should also know what is the direction of the magnetic field, isn't it? Because when you will add those magnetic field, you must be careful about the direction of the magnetic field, right? So now tell me, what is the direction of magnetic field? To look at that, is it the direction of current? And we want to calculate somewhere here. Just think this diagram in your paper, okay, notebook. So you will see the palm is facing out of the plane. So here the magnetic field due to this side is what? Out of the plane. Like that, if you calculate for the other segment, again out of the plane, due to this segment out of the plane, see that every part of this loop is creating magnetic field what? Out of the plane. So this is the magnetic field due to one side, and can you see that all the four side of this square is going to create the same magnetic field? So it means what? If all the sides are creating same magnetic field, can we say the net magnetic field will be 4 times of what we have calculated now? What we have calculated now? Mu naught by 4 pi I A 2 sine 45 1 by root 2 1 by root 2 plus 1 by root 2 2 by root 2 we have. Understood? And what is the direction will come? Direction will come out of the plane because all these magnetic fields are what? Out of the plane. So net magnetic field also will come what? Out of the plane. You can simplify a little bit and get your final answer. 2 and 2 get cancel out with this 4. Right. So what we have? We have root 2 is there. You can write it 2 root 2. So you have 2 root 2 mu naught I by pi and a. So this is the net magnetic field at the center of the square. This is what? This is the net magnetic field at the center of the square we were calculating. Okay, understood? So how do we calculate it? So whenever anything is made of what? A combination of straight segments, what you do? Calculate each straight segment individually, and then if these segments are creating field in the same direction, you will add them. If it is creating in the opposite direction, we will subtract it. Okay, clear? Let's take another example. And same question can come for equilateral triangle. Similar way the answer will come, isn't it? Equilateral triangle, what will happen? In the equilateral triangle, if I'm calculating, then in that case, we should calculate due to one side. And then 3 times we will make it to get the net magnetic field. Okay, let's take one more example. In this example, I'm going to take example of the rectangle. Rectangle, one thing please keep in mind, the angle is not 45 degree, 45 degree. That is one mistake we make it many times whenever we are going to solve the question. Okay, so let's say this side is this side of the rectangle is 2a, other side is a. Okay, a rectangle is there, the side is 2a, and this side is what, a, and this is the center where we want to calculate the magnetic field. Current is given in this direction, clockwise or anti-clockwise, you can say that. Okay, and the current flowing is what, I. Okay, angle how much given, sorry, side is what given, 2a comma a. Find magnetic field at the center. Find magnetic field at the center of rectangular loop. Okay, so please try it and tell me how much is that coming. Please tell me here, will you do it 4 times? Please tell me, are you going to make it 4 times here also? All four sides will give us the same magnetic field or different? Please tell me, all the four sides are creating the same magnetic field or different? So here what will happen, the two side will create the same magnetic field and other two side will also create the same magnetic field. All four sides are not creating the same magnetic field. Understood? Actually, please calculate it and tell me how much is this coming answer for this question. Do the same method, follow the same method, okay? Follow same method and tell me what is the answer coming. Tell me how much is this coming? Calculating this one or not? See, in this one, if I say these two sides are going to create same magnetic field and the other two sides are going to create the same magnetic field, isn't it? Tell me, the two smaller side will create the same magnetic field and the two bigger side are going to create the same magnetic field, right? So let's calculate. Let's calculate due to them. Okay. The first I'm going to calculate due to this smaller side. These are the two ends, and this is going to be what? The perpendicular distance. Okay. So tell me, if I say the alpha beta, can I say the alpha beta are same, theta and theta? Please tell me, can we say this alpha beta are the same theta and theta? So due to that one, if I'm going to calculate the magnetic field, let me call it V1. Can we say B1 will come mu naught by 4 pi I by, what is the perpendicular distance? Is the perpendicular distance is A? Perpendicular distance means a point and wire, that distance, na? The total side is what? 2A, isn't it? Total side is what? 2A. So mu naught by 4 pi I by that perpendicular distance is what? A. And sine alpha sine theta means what? Sine theta plus sine theta. But the problem is we need to calculate the sine theta to answer this further. Okay, now so what we are getting? Mu naught I by 4 pi A into 2 sine theta. And now if you calculate the value of 2 sine theta, Just check it what we are getting after calculating the value of 2 sine theta. Look at that. Look at this triangle. Can you tell me what is the value of sine theta? So in this triangle, is the value of sine theta is a by 2, right? This side is how much? This is a by 2, and this diagonal is how much? A square plus a by 2 square, isn't it? Under root of a square plus a by 2 square, that means a square by 4. So am I getting sine theta value as 4 plus 1, 5, and 2 will come out 1 by root 5. Just check it. So that means sine theta value we will put it as mu naught I by 4 pi a into 2, and in place of sine theta, what we can write it? 1 by root 5. So this is the magnetic field due to what? Due to the two straight section, those black color I have represented. Same thing if I want to do it for the blue color, what I should do it? So for the blue color, perpendicular distance will become what? A by 2. And these two ends are forming what angle? Something phi and something phi angle. That means for this segment, the alpha beta is nothing but pi and phi. So let me call this as the B2. Acha, what is the direction coming? Keep the thumb in the direction of current and fingers where you want direction of current. Fingers where you want to calculate. The palm is facing out of the plane. So here the magnetic field is what? Here the magnetic field is out of the plane. Next, due to blue color, horizontal segment, mu naught by 4 pi, current is I, perpendicular distance is a by root 2, and the angle is alpha beta, both are same, sine phi plus sine phi. So mu naught by 4 pi, 2I by a, and 2 sine phi we can write it. Now if you put the value of sine phi, can you tell me what is the value of sine phi will come? Is the value of sine phi is coming a divided by root 5 a by 2? Please tell me. A divided by, because diagonal will remain same, na? When you are calculating sine phi, the diagonal will remain same. Only the perpendicular will become a this time, right? So sine phi value, if you are calculating, sine phi is coming 2 by root 5. It is coming to us. Okay, 2 by root 5 it is coming. So what is the value we are getting? Mu naught 2I by 4 pi a into 2, and sine phi is 2 by root 5. That direction is also out of the plane. Now, if I want the net magnetic field due to this rectangular loop, can I say the net magnetic field will come 2 times of B1 plus 2 times of B2? And what is going to be the direction? All the magnetic fields are out of the plane. So net magnetic field will also come what? Which direction? It will come out of the plane only. Understand? So whenever you get a question like that, always try to identify. Okay? Always try to identify that. Can you break it into a straight segment? Because you only know the formula of what? The straight segment magnetic field, isn't it? Please tell me. We only know the formula for what? The straight segment magnetic field, not any other. Okay? Please tell me. Clear?
Yes, sir.
Right. Okay. So let's take one more example on this straight conductor. This is x-axis given. This is y-axis given to us. Okay. And a wire is bent in this form. Okay. Let's do one thing. This end is extended up to infinity, and then wire bent in the along the y-axis. This is also infinity, and this is how the current is flowing in the wire. Understood? So it is like what? One end of the wire is at infinity, one end is at the origin. This is x and y axis. Wire is kept along the x and y axis. There is a point. This is the point, and they gave the point coordinate as something x comma y. Okay, where is the point? Point is at x comma y. So they are asking in the question, find net magnetic field, net magnetic field at point P. Okay, actually find it. Again, what you need? You need two things to calculate the magnetic field at any point. The two things are what? What is the perpendicular distance of the point from the wire? And what is the alpha beta angle? Right? These are the two things you need if you want to calculate the magnetic field at any point. Okay. So please tell me how much is this coming? So tell me what is the magnetic field at the point P coming to us? Just separate it once, calculate the magnetic field due to the y-axis conductor, and then calculate the magnetic field for the x-axis conductor. Okay. Tell me, trying this one, are you getting the answer? See, if I want to calculate this one, again, I am going to divide it into two parts. Okay. Let's call this is one infinite part, and this green one is the another infinite part. Okay. Now, due to blue color, if I'm trying to calculate what I need this is the perpendicular distance. How much is that perpendicular distance? If this coordinate is x comma y, can I say this perpendicular distance is x? And the two ends, let's call this angle as alpha. And what will be beta? Can I say beta is going to be approximately 90? Now, if I put the values and try to calculate the magnetic field, let's call the B1, the value will come mu naught by 4 pi I by perpendicular distance x. Perpendicular distance is x and sine alpha. So one angle is what? 90. Other angle is what? Other angle is this one. This one we have to calculate it. Tell me, what is this going to be sine alpha? Is the sine alpha is going to be, what is this value? This value is y. Y by under root of x square plus y square. So how much we got it? mu naught by 4 pi I by x 1 plus y by under root of x square plus y square. What is the direction coming? Keep the thumb in the direction of current and spread the finger where you want to calculate it. The palm is pointing into the plane. Next, B2 if you want to calculate, exact same thing. This is going to be the perpendicular distance, isn't it? What is the perpendicular distance? Y. This angle is, again, what else is needed? Angle is needed. One angle is, let's say, something theta. Other angle is 90 degree. So what is the value will come? Mu naught by 4 pi I by perpendicular distance y. One angle is 90, so sine 90 plus other angle is theta. The value of theta, if you calculate this value, this is how much coming? This is x coming to us. So what is the value of sine theta we have? X divided by under root of x square plus y square. Just simplify it. What we are getting? Mu naught by 4 pi I by y 1 plus x by under root of x square plus y square, and the direction is coming again into the plane. Keep the thumb in the direction of current and fingers where you want to calculate the magnetic field. So the palm is pointing into the plane. Into the plane we represent by cross. Out of the plane we represent by dot. So this is the B1 and a B2. Both are in the same direction. So both are in the same direction. So net magnetic field will be, we just need to add them. And what is the direction will come? Direction will come out of the plane, it will come. Clear? Direction will come which direction? Out of the plane, it will come. So this is what we have about the straight conductor. Now, after we discuss about the circular loop, what is the magnetic field? Then we will discuss the combination of loop and straight portion, how to calculate the magnetic field. Okay, so let's calculate magnetic field due to circular loop. Okay, magnetic field due to circular loop or circular current carrying wire also, you can say that. Okay, so if I'm calculating magnetic field due to circular loop, you see this is the loop, circular loop having some current I, and the radius of the loop is what? Something R. And we want to calculate the magnetic field where? At the center of the loop. Where we want to calculate? We want to calculate the magnetic field at the center of loop. So what will happen if we want to calculate the magnetic field at the center of loop? Again, we will use the Biot-Savart law, isn't it? Biot-Savart law is applicable for every type of conductor. Okay, any conductor is there, we can always apply the Biot-Savart law. Okay, so what will be the small magnetic field at the center? So mu naught by 4 pi I dl. Dl means what? Small part of the loop, a small part of conductor. So dl I dl sine theta. Sine theta means what? Sine theta means, can I say this must be the dl here? dl is what? Dl direction is nothing but the direction of current. So current is flowing along the tangent, na, every point. So that is the dl. And what is r? R is the vector which joins dl and the point where you want to calculate the magnetic field. What is r vector? R vector is the vector which joins dl vector and the point where we want to calculate the magnetic field. So actually that angle is how much? That angle is 90 degree. So IDL, how much is this angle? This angle is sine 90 divided by IDL sine theta by r square. So that vector distance is how much? R square. And you see that here I is a constant. Every element of the loop is making exactly 90-degree angle, isn't it? Because dl is always along the tangent, and small r vector is always along the radius. So that's why they are always perpendicular. So that sine 90 is also not going to change. Next thing, capital R, that is also not going to change. And all the magnetic field is coming which direction? Keep the thumb in the direction of current and fingers where you want to calculate the magnetic field. The palm is facing what? Out of the plane. So magnetic field here will come which direction? It will come out of the plane. So what is the magnetic field at the center of a circular loop? So mu naught 4 pi I r square sine 90 is 1, and dl integration, if you do it, 2 pi r will come, isn't it? Simplify it, pi r and 2. So that is 2 will remain, 1 r will remain. So what is the magnetic field at the center of circular loop? Mu naught I by 2 r will come. So magnetic field at the center of a circular loop is how much? It is mu naught by 2r. Sometime instead of loop, they will give you part of loop. Part of loop means what? The circular arc. So very simple is there. Like if complete loop gives us mu naught I by 2 r magnetic field. So the portion of the arc will give us how much? Just the unitary method, isn't it? So magnetic field due to circular arc, if you are calculating, okay, instead of complete loop, magnetic field, magnetic field due to circular arc we are going to calculate. Okay, due to circular arc, again where? At center. So nothing a new thing will come. We know due to complete loop what is the magnetic field we have. So due to complete loop we know the magnetic field, right? Now we want to calculate due to the circular arc. The circular arc means what? Something like this. Arc is nothing but a part of the circle, and we want to calculate the magnetic field here. This arc is making how much angle? It is making theta angle, and let's say this is the current here. So what is the magnetic field at the center? Again it will come. So magnetic field at the center will be coming mu naught I by 2r. It is because of complete loop, isn't it? And complete loop has how much angle? 360-degree, isn't it? So unitary method, if you apply, you can write it theta degree by 360-degree. Understood? That means what? If this circular arc make 360, this is just a unitary method, isn't it? 360-degree, it gives us mu naught I by 2r magnetic field. 1 degree arc is there, it gives us mu naught I by 2r by 360. Theta degree is the arc angle. How much it will give us? Mu naught I by 2r into theta degree by 360-degree. It just comes from what? From the unitary method. Okay. The magnetic field at the center of a circular loop, how much is that? Mu naught I by 2r. And if you only want to calculate due to part of circular loop, okay, how much it will come? Mu naught I by 2r, theta degree by 360-degree we can apply it. Understood? Please tell me. Please still clear? So sometime you will see the same formula written like this. Magnetic field at the center as mu naught I by 2r, theta by 2 pi. Both are exactly the same thing written. Only difference is what? In the first case, we are keeping the arc angle in degree. And in the second case, we are keeping the arc angle in what? Radian. That is the only difference between the two cases. Okay. Is that clear? Just give me 2 minutes. Okay. I will be back. Okay. Just give me 2 minutes. Okay, so now let's discuss some questions where the combination of straight segment and the loop is given to us. Okay, so due to complete loop at the center, how much it will come? Due to complete loop at the center, how much it will come? It will come mu naught I by 2r will come, right? And if it is a part of the circular loop, right, then how much it will come? Mu naught by 2r into theta by 360. If you are writing the angle in terms of degree, if you are writing in terms of radian, then you can use it mu naught I by 2r theta by 2 pi, we can use it. Okay, now so these are the cases we have. Now let's discuss some more example like that. Okay, now okay, in this example what is given to us? A loop is given like this. Okay, both are circular part only. I'm not making a correct one. Okay, understood. The upper portion has like this current. Same current is flowing throughout the loop. Okay, what is the current? Current is I here. The bigger arc is what? The bigger arc is having 2r radius, and the smaller arc has what? R radius. Okay, Clear? This radius is 2r and this radius is what? R. And this is the common center for both of them. Okay, this is the center for both of them. Now they are asking in the question, find magnetic field at their common center. Okay, let's calculate the magnetic field at their common center. How much is that coming? Actually, please tell me how much is this coming? So please tell me how much is this coming? Can you tell me how much is this coming? Just two semicircular portions are there, na? That's it. Huh? Just two semicircular portions are there. What about the straight segment? You will say sir, two semicircular portion to okay. But what about the straight segment? How much the field will come because of the straight segment? Can I say that it will come zero? Please tell me. Due to a straight segment, will it come zero? Why it will come zero? Because this point where I am trying to calculate the magnetic field, is it along the direction of current itself? So that's why for the straight segment here, no magnetic field will come. Only the magnetic field will come due to one circular loop and other circular loop. And both the circular loop are what? Semicircular in nature. Both the circular loop are what? The semicircular in nature. So let's calculate the B1. So how much B1 will come? Mu naught I by 2R. What is the radius of the loop 1? 2R. But it's not a complete loop, na? It's only semicircular loop. So semicircular loop means what? The theta will be 180 degree. So can I write it here? 180 degree by 360 degree. You could have directly written the half, right? Because you know it's a semicircle, half of the circle. Or if you want to use how it's coming, then the magnetic field due to the part 1. What is the direction coming? Keep the thumb in the direction of current and fingers where you want to calculate. Then palm is facing what? Into the plane. There is another way to find out the magnetic field direction. Curl in the direction of current. Curl your fingers in the direction of current. Then what will happen? The thumb will point towards the direction of magnetic field. So that is also one way. Now B2 if you want to calculate, how much it will come? Mu naught I by 2 times of radius is r and it is also semicircle to 180 degree and 360 degree. Direction is into the plane. So if you want to calculate the net magnetic field due to this loop, what it will come? B1 plus B2 and because both are in the same direction, just put the value mu naught common, I common, 2 common, R common, right? 180 by 360, 1 by 2 again common, right? To 1 by 2 one more time common. So we have 1 by 2 plus 1, direction will come into the plane will come, right? Net magnetic field, what direction it will come? Net magnetic field direction into the plane will come. So mu naught I by 4r and 1 plus 1 by 2. 3 by 2 will come. So that is the direction of what? The net magnetic field. It is into the plane and the magnitude is how much? Mu naught I by 4r into 3 by 2 we have. Clear? So this is the case of what? Combination of straight and circular section. Okay. Let's discuss another example of straight and circular section. Okay. A semicircular portion is given. A straight segment is given. Another straight segment is given to us. This is the center. This is the center. Radius of the circular portion is r. Same current I is flowing throughout. Okay. I, I, I is flowing everywhere. Radius of the semicircular portion is r given to us. Again, they are asking in the question, find net magnetic field. Find net magnetic field at the center. Okay, so please tell me how much is the net magnetic field at the center coming to us. Please tell me how much is coming net magnetic field at the center. Mhm. So tell me how much is this coming? What is the net magnetic field coming at that point? Is it the case of three segment? Two a straight segment, one semicircular segment, isn't it? So this is straight segment one, let me call it this as the two and this as the three. Can you tell me which one of them is going to be zero? You know, one of them is going to be zero. B1, B2, B3. One of them is zero. Can you tell me which one is zero? Out of B1, B2, B3, which one is zero? Is the B3 zero? Right. Why? Because the point where we want to calculate the magnetic field is just along the direction of current only, isn't it? Or behind or forward, no problem. It's still, if the point is lying on the same line as the current direction, then the magnetic field due to that segment will come zero. Now let's calculate one by one all these values. So what is the B1 will come? So one end is here itself, right? The zero angle, other end is infinite. Okay, now it's a long one. And this is also extended up to infinity. So B1, if I am trying to calculate how much it will come, So B1 will come mu naught by 4 pi. Current is I. Perpendicular distance is R. Sine alpha. One angle is 0, other angle is 90, right? So we got it mu naught by 4 pi I by R, and the direction will come. Keep the thumb in the direction of current, fingers where you want to calculate the magnetic field. So the palm is coming into the plane. Next, B2, if I want to calculate mu naught I by 2R, that is due to the complete loop. It's a semicircular. We can make it half. Direction is again what? Into the plane. And what about the B3? B3 is coming 0 to us. So now B1 also into the plane, B2 also into the plane, B3 is 0. The net magnetic field, how much it will come? B1 plus B2. And what is the direction will come? Direction will also come into the plane, it will come. So mu naught I by 4 pi R plus mu naught I by 4R. Direction is into the plane. So you can just simplify mu naught I by 4R common 1 by pi plus 1, and the direction is coming into the plane. Understood? So this is how, if a combination of loop and straight segment is there, then what we will do to calculate the magnetic field. Okay, just one last example, you try to do it. Okay, now in this example what is given, it is something like this. Okay, this is the direction of current given to us in the problem, and these two are the circular arc part. This is the center of the circular arc. Okay, inner one radius is r given, and outer one radius is what? 2r given. Okay, inner radius is what? R given, outer radius is what? 2r given to us, and current I is flowing in this loop. Now they are asking in the question, find magnetic field magnetic field at the center of the loop. Okay, so try this question. Next thing we have to discuss in our class is about magnetic force. Right now we know how the magnetic field will come, right? So we will discuss 2 3 more thing in this chapter, which is the magnetic field using Ampere circuital law. Okay, just like the Gauss law, we have used the electrostatic field calculation. The magnetic field calculation will be done using the Ampere circuital law. Okay, and after that we will discuss about magnetic force on a charged particle and magnetic force on a current carrying conductor. Okay, so these things we will do it after the next week. Okay, so from tomorrow up to next Sunday, our classes won't be there. Okay, na? So again, next we will continue it afterwards. Okay, right, everyone? Please tell me.
Okay, sir.
Okay, yeah, tell me. Okay, so till then, practice the questions. Okay, for this week, just practice all type of questions. Okay, na? And then we will continue with the force on that charge particle, force on the current carrying conductor, and Ampere circuit law. These 3 4 things are left in the magnetism chapter. Okay, right? So let's meet it after the after next week. on 8th onward. Okay. Right. Okay, everyone. Bye, everyone. Take care.